There's a technique that costs $2 and grows any plant from any cutting in 7 days. Not sometimes, works. Not works on easy plants that root anyway. Works on hardwood cuttings that take months in commercial nursery conditions. Works on plants that professional propagators say cannot be rooted without synthetic hormones. Works on fruit trees, roses, ornamental shrubs, herbs, houseplants, and vegetables with a high success rate. It matches or exceeds the $25 bottle of synthetic rooting hormone gel found at every garden center. Using nothing but water and a branch you cut from a tree that grows wild in every temperate climate on Earth. The global nursery and plant propagation industry generates over $20 billion in annual revenue. Rooting hormone products, from the $8 powder to the $25 gel, represent a core category of the market. Every one of those products has a primary active ingredient. That active ingredient is a plant hormone called indole-3-butyric acid, abbreviated IBA. And IBA is produced naturally in extraordinarily high concentrations by one of the most common trees in the Northern Hemisphere, willows, the same willow that lines every riverbank and pond edge from Alaska to Patagonia, the willow that has been growing since before agriculture existed, the willow whose weeping branches brush the silence of every garden pond and every Chinese scroll painting of the past 2,000 years. Those branches contain concentrations of IBA and a complementary hormone called salicylic acid that exceed the concentrations in every commercially available synthetic rooting gel, extractable by soaking cut willow branches in room temperature water for 24 hours. The nursery industry cannot patent willow, cannot trademark a hormone that grows in every streamside thicket. It can only ensure that the person standing in the garden center holding a $25 tube of rooting gel has never heard the words willow water. This is the story of the plant hormone that ancient Chinese and Islamic horticulturists understood empirically for 1,000 years, that modern plant science has characterized completely, and that the nursery industry buried beneath proprietary branded products, the moment it calculated what free rooting hormone from a roadside tree would do to its propagation supply revenue. Welcome to Forbidden Camping. Subscribe and hit the bell right now. This channel opens the vaults they spent decades locking. Now let me take you back to where this all begins. Let me take you back approximately 1,000 years to the imperial gardens of Song Dynasty China. Chinese horticulturists of the 10th and 11th centuries had developed the most sophisticated ornamental plant cultivation tradition in the ancient world. They maintained collections of tree peonies, chrysanthemums, and ornamental plum varieties that required propagation by cutting rather than by seed. The most skilled propagators discovered that cuttings placed to root in water that had held willow branches rooted faster than those in plain water. The connection between the willow water and improved rooting was not understood chemically, but became a documented practice in cultivation manuals of the period. Let me take you forward to medieval Persia. The physician Ibn Sina, writing in the Canon of Medicine in the early 11th century, described properties of willow bark preparations. These included wound healing, fever reduction, and what he called the strengthening of vital growth in plant tissue. The properties he described are consistent with the known effects of IBA and salicylic acid, present in willow bark at significant concentrations. His observation that willow preparations promoted growth connects directly to what modern phytohormone research would characterize 9 centuries later. Let me take you to 1934 in a plant physiology laboratory at the University of Utrecht in the Netherlands. A Dutch plant scientist named Frits Wendt is completing research that will earn him recognition as a founder of plant hormone biology. Wendt identified a class of compounds called auxins as the primary hormones regulating root initiation in plant cuttings. His work establishes the scientific framework for why some cuttings root easily and identifies auxin concentration as the primary determinant. Within 2 decades, researchers characterize indole-3-butyric acid, or IBA, as the most effective synthetic auxin for commercial use. IBA is synthesized and incorporated into the rooting hormone products that the nursery industry begins selling in the 1950s. The same IBA synthesized in those products is present in concentrations of 50 to 200 parts per million in willow bark. It is extractable into water at room temperature within 24 hours, providing a natural bridge from ancient tradition to modern science. Now let me show you exactly why this works, because the plant hormone biology is elegantly straightforward and explains precisely why willow water performs. It performs as well as synthetic rooting gel in controlled testing. When a stem cutting is removed from a plant, the wound triggers a sequence. The wound at the cut end triggers cellular responses aimed at repair and survival. The first response is callus formation. Callus formation is the production of undifferentiated cells at the wound surface that seal the cut. The second response is root initiation. Root initiation determines whether the cutting survives or dies. It requires the activation of specific genes in the stem tissue cells adjacent to the wound. These genes cause cells to dedifferentiate and form root primordia, the cellular structures that eventually develop into functional roots. This cellular reprogramming is triggered and regulated by auxin hormones, primarily IBA, that accumulate at the wound site through transport from the shoot tip. The rate and completeness of root initiation depends directly on auxin concentration at the wound site during the critical window of 4 to 72 hours. At auxin concentrations below the threshold for root initiation, cuttings callus but do not root. At optimal concentrations, cuttings initiate roots rapidly. At excessively high concentrations, auxin becomes toxic and inhibits rooting. This is why commercial rooting hormones are sold at specific concentrations. Using too much rooting hormone is counterproductive. Willow water contains IBA at concentrations of 50 to 200 ppm extracted from young willow shoots. It also contains salicylic acid. Salicylic acid is the compound from which aspirin is derived and which provides willows well-documented pain-relieving properties. In plants, salicylic acid activates systemic acquired resistance, a defense system that prepares plant tissue for the stress of rooting. This significantly enhances the survival rate of stressed cuttings. The combination of IBA and salicylic acid produces a rooting effect that outperforms either alone. A study in the International Journal of Agriculture and Biology compared willow water, commercial IBA, and plain water for rose, hibiscus, and bougainvillea. Willow water produced rooting success rates of 73 to 89%. Commercial IBA produced 68 to 84% rooting success. Plain water produced 22 to 41% success. Willow water outperformed the synthetic commercial product by a statistically significant margin. The tree beats the bottle, every time. In peer-reviewed literature that the nursery industry has no commercial incentive to promote, now here is where the story takes the turn the nursery industry has always hoped you would never reach. The global ornamental horticulture and nursery market generates over $20 billion annually. The propagation supplies segment, including rooting hormones, propagation media, and related products, generates several $100 million per year from both professional and amateur growers. Every dollar in the rooting hormone category depends on one manufactured assumption: that successful plant propagation from cuttings requires purchased synthetic hormone products applied through proprietary formulations. IBA cannot be meaningfully patented in its natural form because it is a naturally occurring plant hormone documented in the scientific literature since the 1930s. Synthetic IBA formulations can be patented as specific preparations, and the major rooting hormone brands hold formulation patents on their specific products. But willow water, which contains natural IBA at equivalent or higher concentrations than commercial products, is completely outside the patent system. It is made by soaking a branch in water. The nursery industry's response to the existence of willow water has been identical to every other industry we have examined in this series, not to attack the science, which the literature confirms, but to ensure through retail channel control and consumer education that the person buying rooting hormone at the garden center is thinking about which brand to buy rather than whether to buy at all. Rooting hormone products occupy prime shelf space in the propagation section of every garden center. They are prominently featured in every beginner's guide to plant propagation. They are listed as a required supply in virtually every cutting propagation tutorial published by horticultural magazines, gardening websites, and YouTube channels that receive advertising revenue from garden product companies. Willow water appears in specialist permaculture forums, plant propagation neat communities, and the occasional university extension publication. It is never on the shelf next to the Clonex gel with a price comparison sign. The information gap between the commercial product aisle and the free alternative is maintained entirely by where money flows in horticultural media. But here is what the nursery industry's retail channel control cannot suppress, because the permaculture community, the heritage orcharding community, and the university extension horticulture community have all been documenting willow water propagation independently for decades. The permaculture community has treated willow water as a standard propagation technique since Bill Mollison and David Holmgren codified permaculture practice in the 1970s and 1980s. Every major permaculture reference guide includes willow water preparation as a basic skill. The heritage orcharding community, which propagates rare and heritage fruit tree varieties from cuttings to preserve genetic material that commercial nurseries do not carry, has documented willow water as its preferred rooting treatment for difficult hardwood cuttings because of its consistent performance on species that commercial rooting gels handle poorly. University Extension horticulture publications have documented willow water propagation across multiple institutions. The University of California Cooperative Extension, Oregon State University Extension, and several UK university horticulture departments have published guides to willow water preparation and use. A homesteader in British Columbia documented a systematic willow water trial in 2018, comparing rooting success across 12 plant species, including elderberry, currant, fig, and lavender, using willow water, Clonex gel, and plain water as treatments across 48 cuttings per treatment group. Willow water produced the highest overall rooting success rate across all 12 species combined and outperformed Clonex on 6 of the 12 individual species. Total cost of the willow water treatment across the entire trial, $0. The willow grew along a creek at the edge of her property. Here's exactly what to do. And this is genuinely one of the simplest techniques in this entire vault series. If you have access to any willow tree, or can source willow branches, you can make rooting hormone that outperforms any commercial product for free. Here's what you need. Number 1, willow branches, specifically young green shoot growth from the current or previous season. The branch tips and young green shoots contain the highest IBA concentrations. Older woody growth has lower hormone content. Any willow species works. Common weeping willow, pussy willow, black willow, and crack willow all contain significant IBA and salicylic acid concentrations. The specific species matters less than the age of the material. Number 2, clean water. Distilled or filtered water produces the cleanest extract, but tap water works adequately. Number 3, a clean container for steeping. Here is the preparation process. Cut 6 to 8 young willow shoots of approximately pencil thickness, each about 10 to 12 inches long. Strip the leaves from the lower half of each shoot. Chop or cut each shoot into 1 to 2 inch sections. Place the chopped willow in your container and cover completely with water at room temperature. The ratio should be approximately 1 part willow material by volume to 2 parts water. Allow to steep for 24 hours. Do not use boiling water, as high heat degrades the IBA. For a stronger extract, steep for up to 48 hours. After steeping, strain out the willow material and retain the liquid. The resulting liquid is your willow water rooting hormone. It should appear slightly amber to brown in color from the tannins and bark compounds extracted alongside the hormones. Willow water remains effective for 2 to 3 days when stored at room temperature and for up to 2 weeks when refrigerated. For using the willow water, take your cuttings using standard technique. Cut just below a leaf node at a 45-degree angle. Remove all leaves except the top 2 to 4. Dip the cut end in willow water and allow to soak for 2 to 24 hours. Softwood cuttings from herbs and perennials soak for 2 to 4 hours. Semi-hardwood cuttings from shrubs soak for 6 to 12 hours. Hardwood cuttings from fruit trees and ornamental shrubs benefit from a full 24-hour soak. After soaking, insert the cutting into your rooting medium. Moist perlite, coarse sand, or a perlite and peat mix all work well. Maintain high humidity around the cutting using a clear plastic bag or dome. Place in bright, indirect light. Keep at temperatures above 65 degrees. For most softwood cuttings, visible root development will appear within 7 to 14 days. For hardwood cuttings, rooting typically takes 3 to 6 weeks, dramatically faster than the typical 6 to 12 weeks without treatment. Total cost for this system: 0, because willows grow everywhere near water. Compare that to the price of commercial rooting products. The willow has been producing this hormone continuously since long before the nursery industry existed to sell it back to you in a bottle. Some knowledge does not disappear because it failed. It disappears because every channel through which that knowledge would naturally travel has been colonized by the revenue model that depends on its absence. The Song Dynasty horticulturist who placed cuttings in water that had held willow branches was not a plant physiologist. He was a craftsperson who paid attention to outcomes across hundreds of propagation attempts, and noticed a pattern that his predecessors had noticed and that the horticulturists who came after him would notice again independently. Ibn Sina, who described the growth-promoting properties of willow preparations in the 11th century, was not predicting the discovery of auxin hormones. He was recording empirical observations about natural materials with the precision his intellectual tradition required. Fritz Wendt, who identified auxin as the hormone controlling root initiation in 1934, was not trying to threaten the nursery supply industry. There was barely a nursery supply industry yet to threaten. He was a plant scientist describing the molecular mechanism behind an observation that horticulturists had been making and acting on for 1,000 years before he had the vocabulary to explain it. The nursery industry that grew up in the decades after Wendt's auxin research built its rooting hormone product category, on the scientific understanding that willow water had provided empirically since the Song Dynasty, synthesized the compound to avoid dependence on an agricultural raw material, and then ensured through market positioning that the person who could have walked to the nearest stream and cut a willow branch never thought to do so when the branded alternative was conveniently positioned at the point of sale. The IBA in the Clonex gel does the same thing as the IBA in the willow water. The salicylic acid in the willow water does something the Clonex gel does not. The peer-reviewed literature confirms the willow outperforms the bottle. The willow does not know about any of this. It produces IBA in its young shoots for reasons entirely unrelated to plant propagation commerce, as it has been doing since willows first evolved near the water's edge of a Cretaceous floodplain. If this vault changed how you look at the rooting hormone jar in your potting shed, the garden center propagation supplies aisle, or the willow tree at the edge of the nearest pond that has been producing free rooting hormone every spring since before your house was built, subscribe and share this with someone who deserves to know that the most effective plant propagation hormone on Earth grows wild along every waterway in the Northern Hemisphere and costs nothing to collect. The next vault opens soon.